Hello, my name is Grace Fernandez, and this is my constant velocity lab. In this presentation, I will go over the introduction, the primary information, and the conclusion. The purpose of this lab was to observe motion of an object that is moving at the same speed and not changing direction. The equations used was Newton's first law of motion, which stated that the net force of this lab was zero because the object moves at a uniform speed. The second law of motion states that the time rate of change of the momentum of a body is equal in both magnitude and direction to the forces imposed on. Therefore, we are able to produce the position update formula used by GlowScript to predict the change of the predicted object. Lastly, the momentum principle states that the change in momentum of a system is equal to the net force applied to it, so the momentum is zero. In the top model on the right, the program tracker is seen being used to collect data and graph points as the object moves across the x-axis. In the second model, GlowScript is seen doing the same thing with the predicted. There's some bigger images. In the graph shown to the right, the red line represents the predicted graph, and the blue line represents the observed graph. The x-axis is time measured in seconds, and the y-axis is position measured in meters. A brief overview of the lab shows the data points are very similar, except for a slight variation in the center of the data. The deviation most likely due to human error. Not just putting in data points. Primary information. The main idea is that an object with a constant velocity will not have any acceleration, and the position should be easily predicted with Newton's second law. The system is the metal object seen moving in the stationary photo, and the surrounding is everything else. The object starts at 0.04 meters with a constant velocity of 0.896 meters per second. That is seen here. That's the system and the surrounding. In the experiment, I observed a moving object with a constant velocity and collected the data through tracker. I adjusted the x-axis to match the measuring tape in the video with the scaling stick, and then marked the position in each frame to get accurate data. After gathering the data, I was able to use it for the graph. For the generic code, I changed the starting position of the vector to 0.0400 meters in order to match the initial position of the object. The velocity was changed to 0.89600 meters per second. The delta t was set to 0.03 because the intervals between recorded data points and the video lasts until 1.2 minutes. So I changed the code to also represent that. Lastly, the ball position variable is set equal to the update formula in order to get the correct updated calculations. Here's my code. In conclusion, the similarities were the points of the graph that were very close, as well as the trend lines were only off by 200ths. The differences were the slight deviation in the middle of the data. Possible areas of the data points were most likely from the handset data points frame by frame. I did that by selecting the exact same piece every time, so I could have messed that up, as well as estimates from the graphs produced by GlowScript for certain points that were missing. Lastly, the simulation extra friction could have been produced on the track via dirt or dust. So the question is, when you analyze your video data in tracker, you made the choice of orientation of the axis. Discuss briefly how your results would change if you were to flip the axes. So my data would most likely stay the same. However, my distance for the x values would become negative instead of being positive. So it just changed that. Lastly, your observation can be predicted well by a computational model. When you set the net force equal to zero in your model, is it possible for you to say how many pushes and pulls are added together to give net force in the case that you observed? Discuss briefly. In the experiment, the force is equals zero because the beginning push set the velocity and did not continue to act on the object, as well as the friction is negligible. On the x-axis, the gravity is equaled out by the normal force acting in the opposite direction. And that is it. Thank you.